Good morning, everyone who just joined. How are you guys doing this morning? I hope everyone is doing well. I want to find out from you guys, how is chemical equilibrium so far? How is chemical equilibrium so far, Nolwazi? Jihad, Hello, how is chemical equilibrium so far? Okay, you're getting there. So does that mean you understand or you getting how equilibrium works? Okay, great. Okay, guys, so today we will be continuing with chemical equilibrium. We'll be doing some questions and some examples as well. And from the previous, the equilibrium constant when you're given the concentration of the product or the reactant. And we also did an example where we were calculating the concentration of the product when we were given the equilibrium constant. And also, we did an example, the one of the table, when you were given the number of moles of the reactants and asked to calculate the equilibrium constant. And I hope you guys will be able to fill this table and be able to calculate the Kc value at the end. We also discussed this question, which might be a multiple choice question. It is a multiple choice question because you're given the Kc equation and you need to choose which one of the following reaction expresses the Kc value given. And we discussed that it's A, because remember, Kc is given by Kc equals to the concentration of the product divided by the concentration of the reactants. And this, I said, you guys must take note of because it can be confusing, especially in questions like this. And we discussed that the equation, the correct reaction of this Kc is A, because as you can see, the products are on the numerator while the reactants are on the denominator. And we also we did this calculation of calculating the Kc value where we were dealing with an ethanoic acid which reacts with ethanol to produce ethyl ethanoate plus water. And in this case, it was the table 1. We were given the number of moles and we're asked to calculate the Kc value. And I hope from all these examples, you have an idea how to tackle different questions. And if you get a question like with the number of moles, you will know what to do. If you get the concentration, you will know what to do. So today we're going to do some examples as well, continuing to do more of this so you guys have more idea of how chemical equilibrium works. So the first example we'll do today, it says cobalt chloride crystals are dissolved in a beaker containing ethanol, and then a few drops of water are added. After a period of time, the reaction reaches equilibrium as follows. So you have your cobalt chloride, which is blue in color, which reacts with water, and it undergoes equilibrium or reaction forward or reverse reaction, and it forms a product. And this product is pink, as you can see, and it forms sodium chloride as a byproduct as well. So the solution, which is now purple, is poured into 3 test tubes. We need to state in each case what color changes, if any. If the color changes will be observed if the following are added into each of the test tube. So A, what will happen to the reaction when 1 centimeter cubed of distilled water is added? So this, we have water in the reactant. So what does this mean? It means that when we increase the volume of the reactant water, it means that we will increase the concentration. So the concentration of the reactant water is increased, therefore the equilibrium will shift to the right. This is the important part about it, that it tells you when the concentration of the reactant is increased, the equilibrium will shift to the right, so the color will become pink. So you must take note of this, that when the reactant or the concentration of the reactant is increased, the equilibrium will shift to the right, and which means that the color of that solution now will become pink. But B says a few crystals of sodium chloride are added. What are we adding now? We're adding the product, meaning you're increasing the concentration of the product which is the sodium chloride. So the concentration of the product is increased, therefore the equilibrium will shift to the left and the color will be blue. Remember, here we have the forward reaction and the reverse reaction. So to summarize what this is, when you increase the concentration of the product, the equilibrium will shift to the left and the color will be pink. So the reverse reaction in this case will be favored. But when you increase the concentration of the reactants, therefore the equilibrium will shift to the right, hence the forward reaction will be favored and the color will be pink. Are we together, guys? It's like you're doubting. Talk to me, Nolwazi. You don't understand the shifting. Okay, let's start again. Let's start with A. So, you have a chemical reaction that's happening. And this so it reaches the equilibrium. So equilibrium can either when you add changes or you do something to it. So let's go back to the notes. When we did the summary, we talk about the factors that affect equilibrium. So it can either be temperature, concentration, or the pressure. So meaning if you increase the concentration, if you decrease the concentration, if you increase the pressure or decrease it, if you increase, it will have an effect on the equilibrium. This is what's happening in this case. We know that this reaction is now in equilibrium, right? And this solution, when this reaction, when it's in equilibrium, the reactant and the product, they have different colors. The reactant has a blue color, as you can see, and the product has a pink color. And now the solution is now purple. The whole solution is purple. But when we started, the reactants were blue and the product that is formed was pink. Now we need to state what will happen to the reaction and the equilibrium. What will happen to the equilibrium state when these are added? A, you add water or you increase the concentration of water. Remember, concentration affects equilibrium. So if you increase the concentration of water, which is the reactant, something will happen to the equilibrium. What is that effect that the increase in the concentration of water will do to the equilibrium? It will shift the equilibrium to the right, meaning the forward reaction, which is this one, will be favored. When what does the forward reaction means? It means that you have your reactants that will form the product. That's what the forward reaction means. It means that the equilibrium will shift to the left, meaning the forward reaction will be favored. So hence the color of the solution now, the color will be pink. That the color will change and it will be observed to be pink. And what will happen now if you add a few crystals of sodium chloride? Sodium chloride is the product of this reaction, which is in equilibrium. So in other words, you are increasing the concentration of the product. And what will happen? How will increasing the concentration of the product affect the equilibrium? So the affecting of equilibrium, it doesn't mean it will decrease or it will change. It will either shift to the right or to the left. So with you increasing the concentration of the product, the equilibrium will shift to the left. What does this mean? It means that the reverse reaction is favored. This reaction will be favored. What does it mean? It means that the products, they react to form the reactant, hence the color now that will be absorbed, it will be blue. So it comes back to us knowing how temperature, concentration, and pressure affect equilibrium. So this is what we are discussing here now. Is Nolazi, do you get it now? Or you have more questions? Okay. So do you understand it? So, okay. Let me summarize this. You have your reactants. They undergo, this is a chemical reaction, and it reaches an equilibrium. This reaction is in equilibrium. This is our reactants, this is our forward and our reverse reaction, and forms the product. So this shows that this is equilibrium, right? The first question asks us what will happen if you increase the concentration of the reactants. As you can see, the forward reaction is favored, meaning the equilibrium shifts to the right. And now the color will be pink because the right side have a pink color. But what will happen when the concentration of the product is increased, which is B, which is sodium chloride? Something will happen to the equilibrium. Now that we are increasing the product, the concentration of the product, something will happen to the equilibrium. It means that the equilibrium will shift to the left and the reverse reaction will be favored. Hence, the color now will be blue because the product reacts to form the reactant. Are we together, guys? Okay, I hope you understand that. Now let's move on to the next example. So we must be able to explain equilibrium in terms of graphs. Graphs are very important in chemical equilibrium. And this example, it will show us that. So in this case as well, I used my X and Y so that to explain to you guys how you can explain or tackle a graph question related chemical equilibrium. In this question, it says consider the following equilibrium system. This tells you that this reaction is already in equilibrium. So you have your reaction, which is x2 plus 2y, the forward and the reversible reaction, to give us the product, which is x2xy. And you're given this is very important. And I hope you remember from the rate of reactions when we discussed graph, I mentioned that you must know that when the enthalpy change is greater than 0, which reaction is this? Which reaction is enthalpy greater than 0? Is it endothermic? Is it exothermic? This is given for a reason because you need to know if this reaction is endothermic or exothermic. So what is the enthalpy greater than 0? Is it endothermic or exothermic reaction? I hope you guys remember that. Is it endothermic or an exothermic reaction? When H is greater than 0 or when the enthalpy is greater than 0. What is the type of the reaction, guys? Yes, it's an endothermic reaction. So what does this mean? It means that if they give you this change in H greater than 0, it means that the forward reaction will be endothermic. Of that when you're forward, when you're given this to be the enthalpy greater than 0, the forward reaction is endothermic and the reverse will be exothermic. But if this was the enthalpy less than 0, it means that the forward will be exothermic and the reverse will be endothermic. But in this case, the forward is endothermic and the reverse is exothermic. Now the question says draw a graph of reaction rate versus time to show each of the following changes to the equilibrium. So these are the changes of the factors that can affect the equilibrium system. And it says after each change of the equilibrium is restored. So I already have my reaction rate, which is on the y-axis, and the time, which is on the x-axis. And the first change is the reaction reaches 1.1 says the reaction reaches equilibrium for the first time after 6 seconds. So I have these two here, so I will use black, the straight line, to be the forward reaction, and I will use the red with the dotted lines to be the reverse. So every time you draw this graph, you need to show the reverse and the forward reaction, and you will see why as I explain. So we note that the reaction reaches equilibrium after 6 seconds. So what does this mean? We have the forward reaction. It reaches equilibrium at 6 seconds. The same as the reverse reaction. It reaches equilibrium at 6 seconds. That's 1.1. That's all you need to do for 1.1 to show that both the forward and the reverse reaction, they reach equilibrium. Now, after 12 seconds, the concentration of X2Y2 is increased. What is X2Y2? Is the product. So we know that the concentration of the product is increased. What does this mean? What happens to the equilibrium? So when the concentration of the product is increased, which reaction will be favored? It will be the reverse reaction. Why is it the reverse reaction? Remember, when you increase the concentration of the product, the equilibrium will shift to the left. The equilibrium will shift to the left, which is the reverse reaction. So it means that the reverse reaction will be favored. And now, what does this mean? It means that from at 12 seconds, the reaction rate of the reverse, a new equilibrium will be established, meaning there will be an increase in the equilibrium of the reverse reaction. Why? Because the reverse reaction is favored and the equilibrium, it shifts to the right. So it means in this case, when you increase the concentration of the product, the equilibrium will shift to the left and the reverse reaction will be favored. Hence, there will be an increase in the reaction rate of the reverse, while the forward reaction stays the same. So this is 1.2. And here with 1.2 at 12 seconds, you're showing that when you increase this product, the concentration of the product, the reverse will be favored, meaning the equilibrium will shift to the left, hence the reverse will be favored and a new equilibrium will be established, and that will increase the reaction rate of the reverse. That's 1.2. 1.3 says after 18 seconds, a catalyst is added. When a catalyst is added, we need to take note that a catalyst does not disturb equilibrium. And when a catalyst is added, it will increase both the reaction rate for both reaction equally, meaning both the forward and the reaction and the forward and the reverse reaction will both increase at the same time. What does this mean? After equilibrium, the reactions are restored, so we go back to the normal state, the same as the forward. It will need to go to the same space as that. Now we're at 18 seconds. We are told that when the catalyst is added, both the reaction will increase, which means that from here we know that the forward will increase as well as the reverse reaction will also increase. So they both increase because of the addition of the catalyst. And when the reaction is, so from here we go to 1.4. So this is 1.3. I forgot to label it. And after 24 seconds, the pressure of the system is increased. What will happen to the reactions, the forward and the reverse reaction, when the pressure is increased? So the increasing of the pressure, it means that the reaction that reduces the pressure, or the reaction that will have or will form less or fewer particles, it will be favored. So think about it. You're increasing the pressure of the system, and the reaction with that will reduce the pressure, or that will have a few particles, it will be favored. Think of it in this way. What will happen when you react the reactants, which is X and Y? This will have few particles because they're forming the product. But with the product is decomposition, because you're moving from the product to produce reactant. So in this case, it means that the forward reaction will be favored because the reactant will have few particles compared to the product that is being formed. Hence, in this case, when the pressure is increased, the forward reaction will be favored because the reactant will have a few gas particles. Hence, it will reduce the pressure and the forward reaction will be favored. It means at 24, so this was the restoration, forgot to write that. After 24 seconds, it means that the forward reaction will increase because it will be favored due to it will have few particles that will form when the pressure is increased, and the reaction rate will increase, and that will be at 24 seconds. And then after that, the equilibrium will be restored. Now, to summarize everything I've just said, we're talking about factors that affect equilibrium. As you can see, the equilibrium 1.1, the system reaches equilibrium after 6 seconds. And after 12 seconds, when you increase the concentration of the product, the reverse reaction will be favored because the equilibrium shifts to the left side. It means that the reverse will increase, the reaction rate of the reverse will increase. And after that, it will be restored and it will be the same with the forward. At 1.3, after 18 seconds, a catalyst is added. And with a catalyst, we know that it does not disturb the equilibrium, but it will increase both the reaction rates for the forward and the reaction. And after 24 seconds, when the pressure of the system is increased, it means that the reaction that will form fewer particles or that will reduce the pressure, it will be favored, and in this case it will be the forward reaction. Hence the forward reaction will increase the reaction rate. And that's how you answer this question. Are we together, guys? And any questions? Yes. Most of the time you need to know this equilibrium graph. To be honest with you, some can come, most of the time it has to be, this is the reaction rate. This is the reaction rate. Sometimes they can say what will happen to the concentration and time. Most of the time it's like this, but they can say T1, T2, T3. Here it was T1, T2, T3, T4. I think this is maybe the list it can go. Sometimes it can just be T1 and T2. But the main aim of this is to understand the factors that affect the equilibrium. So this is the graph. This is how basically the graphs of equilibrium looks like. And they can either, in this case, they gave us concentration, catalyst, and pressure. Sometimes they can ask you in terms of temperature. You must be able to explain that. Here they were saying increase, but sometimes the question can be like decrease. Not only will I have to study the theory, but the structure of the graph too. Definitely. I need to practice or study this. This really need practice. Because as you can see, 1.2 said what will happen if the concentration is increased. But the same question can come and say what will happen if this concentration of the product is decreased. So you need to know what will happen to both the reaction. So it really needs practice. It really needs more time. So this is how most of the concentrations or the graphs looks like when you're talking about the reaction rate of the forward and the reverse reaction. Any other questions, guys? That's why I say please start studying for the exam now, because this, ma'am, who's going to set the exam? The exam is set by, this is grade 12. The exam is set by Mr. Vander Veldhuizen. So this is chemical equilibrium and it's terms 2's work. It's definitely in the exam. Paper 2, it's there. And I think I'll give you guys all the scope for all the papers on Monday while I've written down. And will you guys want me to give you in class, or I must have a Word document or something? How will you want the scope, guys? I want to find out from you. Okay, I'll try to do that. Any other questions, guys, regarding chemical equilibrium? Because this is our last lesson this week. regarding chemi. I wish we could do more examples so I can show you guys how to work this graphs, how to calculate the number of moles. Because next week we're starting with acids and bases. Yes. Mm-hmm. I think with chemical equilibrium, I see the project you're talking about. Because remember, sometimes when you do practicals or experiments, you have a solvent. You can, for an example, you can't just take hydrochloric acid and just dissolve it in anything. You need to have a solvent. So you think that that chemical that you think that it's not a catalyst or anything is the solvent you need to form liquid hydrochloric acid. So, but with chemical equilibrium, it's different. In chemical equilibrium, you are told that you have X, Y that reacts together to form the product. And since it's chemical equilibrium, it can either reverse from the forward where you have reactants that form the product, or the product from the product. So those are two different things. With chemical equilibrium, they will even tell you that, okay, in this reaction, x2 plus 2y, if you add your catalyst, which is hydrochloric acid, that can be a catalyst, because they will tell you that a catalyst is hydrochloric acid. And I think as we go do acids and base next week, you will be able to see how a catalyst is, what is a catalyst, and how it can be used, because it cannot be any compound. I hope you get that, Refilwe. But in chemical equilibrium, in terms of catalyst, you just need to know what happens to the equilibrium. How does adding a catalyst into a reaction affect the equilibrium? Like in this case, this is an example that will help you remember that every time you add a catalyst to a reaction, both the forward and the reverse will increase. So please take note of that. That tells you that, okay, a catalyst affects chemical equilibrium in this way. Any other questions, guys? If you guys don't have any questions, I'll encourage every one of you guys that please start studying for the exams. And if you have any questions as you are practicing, feel free to text me and ask me. I'm more than open to help you guys, because I know how chemical equilibrium, it looks simple until you have to sit down and do the questions on your own. So please feel free to ask me when you are doing the questions. If you're doing the reaction rate and you still don't understand the graphs, ask me as well. But I think today, if you don't have anything else to ask or to say, we'll end our lesson here today, and I'll see you guys in our next lesson. Bye everyone, have a great day further.